for most valves, they generalize it, you know. So most valves go have the body, they go have a bonnet or cover, right? So anybody at all, feel free to answer. Well, you know, some valve class, the cover has the bonnet. For which valve you will say have a cover and which have bonnet? From what you observed from last week, if we're talking about a valve with a cover, what type of valve we looking at?
Oh,
anybody?
Fucking guns.
Crystal, I got a call name. A valve with a cover. All right, somebody, valve with a bonnet.
Gate valve.
You hear me, boy?
Gate valve.
Yeah, we hear it. But to me, I thought all the valve had a bonnet.
Right, now, we are going on with that now. Smooth, like you, right?
Correct.
Right, here we're going on with that. The class all valve as having a bonnet, but really and truly, if you look at the check valve bonnet is really a cover, right? But for one text have it for ease labeling the parts, right? Because bonnet is obviously on most valve. If you look at a clove valve, a gate valve, right? They have bonnet, right? The top work coming to the body of the valve is the bonnet, right? But when you look at the check valve, the swing check have a cover, right? But some go class it as a bonnet for you not to get more or less confused now. But really and truly, the correct term is the cover for the check valve, right? Remember what the check valve look like, the big bolted one? You just have a flat cover and you just hook up to the cover, you know, right?
Yeah.
So that's why for the reading here, they put a bonnet or cover, right? So you could either have a cover or it have a bonnet, right? Then it have the valve this. Valve have trims in it, right? Valve will have a stem, they have a pressure sealing connection. Right? So we're looking at these parts now. Valve body. The valve body directs the flow of fluid to the valve and provides the mounting for the internal part, right? So what the valve body do, it directs the flow of the fluid to the valve. And it also will provide a mounting for the internal parts. And we go check out some of the internal parts just now. Valve body and bonnet material includes, right? So these are some of the material the valve could be made out of. Alloy steel, aluminum, cast bronze, cast iron, cast steel, ductile iron, and the list goes on. Right? If you look, you can make out of plastic, the PVC, and stainless steel too. Valve bonnet. The valve bonnet is mounted on the valve body to complete the pressure casing. It may contain a stuffing box or packing gland area to prevent the fluid from migrating out from the valve stem. So the main use, now even though we talking about the valve bonnet, they come and tell you, hey, within the bonnet, it could contain it, not all might have it, a stuffing box and a packing gland area, right? And that is to do what? To prevent fluid from migrating out from the valve stem, right? The upper work, such as the yoke or other operating mechanism that acts to move the valve stem, are mounted on the bonnet. Threaded bonnets are more commonly used with general purpose valve. So if a general purpose valve, you'll see a threaded bonnet. The bolted bonnet is most commonly used, designed for large high pressure valve. So once you see bolted bonnet, you know it's a high pressure valve. It isn't bound to be a large valve because you could have a 2-inch inch and a half with bolted bonnets too, right? Just remember the bolted bonnets mean it's a high pressure valve. Threaded bonnet is for more general purpose, right? All you remember that?
Yeah.
Then you have bonnetless white pattern globe valve, right? Now, remember, the bonnet is the part that is bolted onto the body. If you look at this valve is a one-piece valve, right? Somebody ask the question, what this piece doing here with the bolts, right? Now, what's going on with this piece here? If you look, this piece is this area is where we contain the stuffing, right? And this, are you seeing the cursor by chance? The area where the cursor on, that is right. That's the packing gland, right? And what the packing gland does do, the gland flange, which is this piece here with the bolts, you just tighten the gland flange, and it just squeeze the gland to compress the packing to prevent liquid from coming onto the stem. Yeah. So that is what this piece is doing here. It's not that you could unbolt this valve really. When you unbolt this valve, it's really to change the packing. The only piece we can unbolt is this area where the gland. I'll just back up, right. The only piece we can unbolt on this is this area here. We have the gland flange here. So you could take out the gland and change the packing, right? But you can't really separate that valve more than that. The service we could do on this valve is more or less for the packing, right? Any question? Right. Now, if we look good, you're going to see like show you the arrow, right? And we know, hey, there's a globe, they say that a Y pattern. You have the arrow, you have the half inch, you have the body material A105, right? Moving on. Valve this. Valve this is the part that control the flow through the valve body. So this is the part that will control the flow through the valve body, right? Remember, the valve body will permit flow to pass through the valve, but this is really the part for controlling the flow, right? Ball valve and plug valve have either a ball or tapered plug configuration for a disc. In most valves, the disc is forced against stationary seat to shut off the flow by the action of the valve stem, right? So the valve stem is really used to hold the disc against the seat to shut off flow. That is what it's saying. The disc is considered part of the valve casing because it is under the same pressure as the valve body and bonnet when the valve is in the closed position. So, they say here, well, in other words, the disc, even though some might say that it's a trim, it's really considered part of the valve casing because that disc is supposed to withstand the same pressure as the valve body and the bonnet. You have a knife gate valve, right? A knife gate valve. These valve features a flat disc against two parallel seats, right? So this is this area where it go in the groove, it fits in the groove, that is the seat, right? The knife gate valve have a sharp edge on the bottom to share or separate slurry, right? Ball valve. The ball valve the disc used for the ball valve is based on a spherical shape, ball-like shape, right? A hole is drilled through the center of the ball for passage of fluid, right? So this is your disc or your ball here, right? A hole is drilled through here, for the passage of fluid. This stem area here, right, which is going on here and contain the handle. But this stem will have a little piece like a tongue, what fit on this inside this ball groove here. So once you turn the stem and the tongue inside this groove here, you go rotate the ball at a 90-degree, a rotary motion. Right? This is your part of your ball valve. Then you have a next type of ball valve here now. This is a trunnion ball valve. Right?
Tomorrow.
So talking about the trunnion ball valve, they say this valve incorporates a cylindrical shape on the opposite side of the ball. Right? So this is your shape here, looking like a ball, but at the same time, the opposite side, right, which is this, have a cylindrical shape, right? Kind of straight shape like this, right? This allows the ball to be mounted on a set of bearings that reduce the thrust to rotate the ball. This here, this piece where they're showing you on top here now, right? This is your set of bearings, right? This is your set of bearings. So they give you one view right here, parts curve like a ball, has a spherical shape, and part like the cylinder. But this bearing here, I don't know where that bearing there. A bearing is like a ball bearing action, right? So it didn't bound to have slug, but it go help this member here to rotate. So once the handle go on top of it, right, it will be easier to rotate, right, because of the bearings. There are bearings to the top and bottom, right? So it will be easier to turn. Any questions? All right. Plug valve or cock or stopcock valve. The plug valve is one of the most widely used valves for on-off. Here they say unthrottling, but we know it isn't really designed for much throttling purpose, right? If the liquid in the system flowing at a low pressure, you could throttle with it. If it's a high pressure, it's on-off service, right? Their design is simple. The body comprises of 3 parts. When I mean 3 parts, 3 main parts. You have the body, you have a cover, and you have the plug. The plug can be cylindrical, tapered, or cone shape. Tapered or cone shape, right? Taper and cone shape is the same thing, right? So you could use taper or you could call it cone shape. The valve is open or closed by rotation. These valves can be metal to metal seat or lubricated seal. Right? Metal to metal have problems with galling and sticking. Right? The use of lubrication between the plug face and seat eliminate most of these problems. Lubricant help control leakage around the plug. It reduces wear between the valve control surface and slightly lift the plug to reduce operating torque. Right? To reduce that strain when you're turning it. The lubricant, the grease, slightly give it a lift. You have your diaphragm valve. The disc of the diaphragm valve is mounted into the seating sides of the bonnet, right? Gasket as part of the valve, right? So the disc on the diaphragm valve is mounted into the seating side of the bonnet gasket as part of the gasket, right? The stem is attached to a carrier mounted in the top of the bonnet gasket from the center of the diaphragm to open or close the valve, right? two type of diaphragm valve. Are the wear diaphragm valve. They say a cutaway, right? But the cutaway just mean the cut through and the showing you. So you have the wear diaphragm valve and you have the straight diaphragm valve, right? This is the diaphragm mounted, right? It's mounted as part of the top work here. And what has happened now is a rubber, and when you screw it, what has happened is stretch the rubber down till it reaches the bottom and it lock off the passage of fluid, right? Same thing here with this one. But this one now, it have a wear or a rise like a dam bank. So when you tighten down the handle, this diaphragm will come and compress against this little wear or bank inside it, and then go stop the passage of fluid. We have a valve we call a pinch valve. Why we didn't mention a pinch valve? A pinch valve is based on the concept of a diaphragm valve. Remember, in the earlies, they say it have 8 basic type of valve, but different valve pattern and valve design. If you look at most of the control valve have one at the closer mechanism. Either is a ball, is a diaphragm, is a gate, right? But it's considered a control valve. So a pinch valve have an action just like a diaphragm valve. I had a little video to show you. Probably you could just watch the video, but you mightn't hear the man describing the part side, right? But we can still watch it and see how the pinch valve operate, right? These valves can use a diaphragm actuator to close the valve, right?
So what is it? What makes it so similar with the pinch and the diaphragm, the actuator or the
Right.
what making the pinch and the diaphragm so similar now?
Right. If we go back, now we will see it in the video too, but let me just look at the diaphragm here, the diaphragm valve. The diaphragm valve have this rubber, right? The rubber diaphragm, which come in and squeeze against the seat in here, or the wear to close the valve, or the rubber diaphragm flexing straight down to the bottom of the valve to close it, right? When we look at the pinch valve now, they say the pinch valve use a diaphragm actuator to close the valve, right? They use this sort of rubber actuator or diaphragm actuator to close it. For high line pressure, large diaphragm assembly are available for additional thrust, right? Air to close actuator can also be used to close the valve when the valve is normally in the open position. Meaning you could use a control actuator to close it, or they use the air to open or close it, right? They tell you here it have an open pinch valve here, A, and B, a manual pinch valve. So let me see the operation. Now you mightn't hear it, but you will see the operation, right? So just look at the operation of the valve. Right. Now, you see the operation of this valve? This valve have a elastic or rubber type diaphragm here. And you have this bar coming and they have it top and bottom at the valve, and this bar. Now you mightn't see it good here. Gosh. But it have a actually have a rod coming down and pinching it. Right? The rod controlling this mechanism was squeezing rubber together. I'm sure you might pick it up from this. Right. You see this rod here? This rod is really the operating mechanism we're controlling here, the bottom and the top. So once you start to close this valve, this rod causing the two seats to come together and pinch the diaphragm or pinch or squeeze the rubber, right? Hence they call it a pinch valve. You see it similar, it have a similar appearance to a diaphragm valve. So it could be classed under the diaphragm. So when they tell you 8 category of valve, they didn't mention the pinch valve because the pinch valve would not fall under the category of a diaphragm valve. All you understand what I said?
Yeah.
Any questions? You talk to me now, I feel like I'm talking to myself.
Yeah. You're sounding good there.
Yeah. Yeah, but what I'm really trying to, what is the similarity to explain now? Because I see it in the question, in the thing, so that's the one I have to make sure now.
With the similarity is this. The operating with this kind of rubber diaphragm, the elastoma rubber. You see the rubber here?
Yeah. So if I have to explain it verbally, we're going to say it is a rubber.
Well, the similarity is they operate on the same principle of squeezing the elastoma rubber, right, against the seat, right? In this case, it's the two seats squeezing the rubber. If you go back to the diaphragm valve, right, is this stem will come in and squeeze the rubber against the seat, right? So the similarity is the rubber is being squeezed against the seat, or the diaphragm is being jammed against the seat, right? Right? So the seat coming together here, but with the diaphragm, it's just the handle coming and jam the rubber against the seat, right? The similarity is the coming together, the rubber and the seat to stop and open flow. Simply put, right? They can't get it wrong. You understand?
Right. Yeah.
Smoke, you go send it for me.
So we're looking at valve trim now, right? Now, remember to mention the disc could be classified as part of the valve body itself, right? Because it's under the same pressure. But yet still, I come back and I put the disc here. I tell you the disc is part of the trim. I'm going to try and close them when I talk about this. Right. So the following are considered as valve trim. So once we're talking about the trim, we're talking about seat. You look at the disc, the gland, right? Have a spacer. It have bushing, right? All you know is bushing, right? A bushing is just a piece that you compress. Now when you're talking about bushing, the seaters, some seaters fit like a bushing, in which you compress it inside the groove, right? And some might have springs also, right? When we look at valve with spring, we're looking at the relief valve, right? Some of the check valve have spring also. So valve trim. Valve trim perform their function while in direct contact with the fluid being processed, right? So So here, the trim will be in contact with the fluid, not all the time, right? And not all trims will be in contact with the fluid, but majority of them. Trims are made from different material than the body, bonnet, valve, stem, and the packing, right? Careful consideration to the effect the fluid may have on the trim component must be taken into account by the designer, right? In this case, I'll add by the engineer, right? Depending on what passing through the line, I don't know what your example like the valve seat, right? Depending on what liquid passing through the line, you're going to know what type of seating arrangement you want. In the case of the diaphragm valve and them, depending on the temperature passing through the line, you'll get a rubber to suit the temperature passing through the line, right? Valve seat. Globe and check valve have a single seat that forms a seal when the disc surface, that forms a seal with the disc surface to prevent flow, right? They have a single seat. Some gate might have 2 seats, right? But globe and check valve have a single seat, right? That forms a seal with a disc surface to prevent flow. Gate valve have 2 seat surface, one upstream, the other downstream of the disc or wedge. The ball valve may have 1 seating surface depending on the number of ports, 1 or more, depending on the number of ports the ball have. Lubricated plug valve use a tapered plug that is lapped into the plug seat in the valve body, right? The line plug valve is one that have a polymer lining inside the valve body to form a seal. When you look at a butterfly valve here and the seating. Butterfly valve have 2 main variations of seating the disc in the closed position. So 2 main variations of seating the disc is available with a butterfly valve. You have the elastoma line bore, which is a rubber lining around the bore of the valve, right? And then you have offsetting the disc plate from the axis. So if it's metal, this kind of offset the disc plate, meaning that the seat and the disc go, it wouldn't be in line like how we have the disc going in between the seat for the gate valve, right? With the butterfly valve now, you have a sort of offset between it because this metal plate going and rest against the next metal plate, right? So you have an offset, one lapping on top of the other more or less, right? Metallic seals are available that allow the butterfly valve to be used for a wide range of fluid at high temperature. So the elastoma rubber, if you want to use this butterfly valve at high temperature, they tell you metal seal are available, right? So instead of the elastoma rubber forming a seal, you have these metal seals available in this case. Regrinding swing check valve design. You can insert a grinding tool through the angle of a regrinding swing check and regrind the valve seat. What that mean? You could use any, say, a pencil grinder, if it's a big one, you could use a 4-inch grinder to help regrind the seat. So that's why they consider it a grinding swing check valve. Sometimes, depending on what the material make out of, before you regrind a seat, you build it up, right? So say the seat start to have cavitation or or say like the wormhole effect on it. You could build up that, like do a padding on it and use the grinder and grind it back and polish it so that the seat can sit down and rest properly against it, right? These valves are suitable for condition, right? They say condensate water, you could do condensate, which is steam. You could use it on water. You could use it for gas. You could use it on airline with low velocity and non-pulsing flow. So more or less, this is like low velocity, it's not a turbulent flow, right? So once you see non-pulsing or smooth flow, you could use these valves with, right? But you could use it on condensate, which is steam line. You could use them for water. You could use them for gas. You could use them on airline, right? And if you look here, you have two different categories on it, oil, water, and gas, and then you have the steam here. So 125 working steam pressure, and you have a 250 for water, oil, and gas, right? So this check valve. Now, pay attention to the disc. Remember we talk about the linear and rotary disc. Swing check, tilt check is considered rotary disc because it's only 90-degree at making, more or less. What did you just say? That's making a little thing almost the 90 here. Because you're moving from 180 almost to 90 to open and close the swing check, right? The unique design gives excellent tightness and minimum water hammering, right? The design of the valve allows it to open at very low flow velocity, right? And I give you a number here, down to 600 millimeter, which is 2 feet per second. So even though, what I'm saying, even though it's mild flow, right? This valve will still swing open, and once the flow drops, it will close, right? So you can operate at low pressure. No problem, it will swing, right? Control valve. Control valve are designed to throttle and are expected to provide some type of shut-off capability. A control valve ability to shut off is affected by the type of valve. Example, is a single or double-seated control valve. This is double-seated have very poor shut-off capability, right? So if it's a single seat, it has better shut-off capability than a double seat for a control valve. It could be affected by the type of guidance, by seat material, right? By the actuator thrust, how hard the actuator pressing to hold this seat down, by pressure drop, by the type of fluid, right? Type of fluid could influence how good it sit on the valve. This sits on the seat, right? Control valve. What is a control valve? This is supposed to be a video, but we know we can't see the video on the control valve. We didn't hear the explanation behind it, right? Valve seat. It is difficult to make a leak-tight valve with metal-to-metal seating surface. The petrochemical and refinery industry codes such as API 600 and ASME B16.34 and MSS SP61 allow for a small amount of leakage between the valve disc and the valve seat. So what I'm telling you that even though a valve is shut off, right, it might have a slight seepage of liquid, right? A slight seepage at the medium of flowing through the valve. Hence the reason why when working on a valve, You just don't depend on that next valve to shut off the system. You blind the system off too, right? You use blank flange, you use slip blind, and blank the system off. You just don't depend on that valve to say, boy, yes, this valve will lock off, this valve locking off entirely, right? Because the cater for a small amount might be seeping through still, right? The method of setting valve seat can be, so in that different ways the valve could be, you could set a valve seat, or a valve seat is installed in the body of the valve, right? Cast and machine into the body of the valve, right? You could cast it, you could build it in one time and machine it in place, right? You could have renewable, replaceable seat. So some the renewable and replaceable now. Small valve use screw in, wedge in, right? Some is welded or brazed into the valve body, right? Large valve may use one of these techniques or may have a seat surface cast or forged into the body of the valve, built in one time into the body, right? Once a seat built in one time, when it's time to repair it, once the valve big, you could always weld back the seat and regrind it, right? The best seats in valve is the screw seats and the easiest one to change, right? Where you just unscrew the seat in and you lift it on and you replace it back with a new one and screw it in. Valve stem. Let me check the time. Right now, let me just take a 5 minutes break before we just do valve stem. Just we get a little drink of water and I'll come back and we start in 5 minutes time. So we starting back at 25 to 7 and we're going to look at the different type of valve stem now, right? All right, so 5 minutes break. Everybody hear that?
Yeah.
Yes, sir.
All right.
Yeah.
Anybody not care, see no more.